In this video, I'm going to continue with the proving of trig identities using the basic fundamental identities that we discussed in the last couple of videos. So just as a review, here we have tangent theta, quotient identities is equal to sine theta over cosine theta. Cotangent theta is cosine theta over sine theta. Okay, so when you see one, say you see tangent of theta, you know that's sine theta over cosine theta. Or if you see sine theta over cosine theta, you know you can replace it by tangent of theta, and so on. The reciprocal identities, cosecant of theta is equal to 1 over sine theta. Okay, so those are interchangeable. At the same way, sine theta is 1 over cosecant of theta. Secant theta is 1 over cosine, so cosine theta is 1 over secant. Okay, so keep that in mind. The Pythagorean identities. Okay, so anytime you see sine squared of an angle plus cosine squared of the same angle, you know that's going to equal to 1. Or if you see tangent squared of an angle plus 1, you know that's secant squared, okay, of that same angle. Or if you see secant squared of an angle minus 1, you know that's tangent squared of the angle. Okay, so those are the same thing. Then you have your even odd identities. Mentioned last time that the cosine function and the secant function are even and the others are odd. And again, mentioned that even functions have graphs that are symmetric with respect to the y-axis, and odd functions have graphs that are symmetric about the origin. Okay. So in the last video, I looked at proving these right here. Okay, so I did these in the last video. And then I mentioned that when you prove an identity, you generally select one side, and generally you want to select the more complicated side and show how you get the other side, the more simpler side. Okay, sometimes they're of equal complexity, so it doesn't really matter, but in some cases one side, working with one side could be easier than working with the other. So it's just things that it's going to take practice. Okay, and we did this one here. So what are the things that you're going to use? Well, a lot of it's going to be algebra. Okay, so whenever you have a rational expression involving the trig functions, like in number 4 here that I did last time, you can try to combine, find the LCD, and see if you can get it to simplify to get the other side. Okay, or if you have a fraction with a numerator involving trig functions, the denominator involving trig functions, maybe you can factor it. Try to cancel it down, reduce it, simplify it, and maybe you can get the other side. You're allowed to multiply both, but the numerator and the denominator by the same expression, as long as you're not multiplying by 0. Okay. So let's look at the one I'm going to look at today. Okay. So the first one I'm going to look at in this video is number 5 here. Sine cubed of x plus cosine cubed of x over 1 minus 2 cosine squared of x is supposed to equal to secant x minus sine of x over tangent x minus 1. Okay, so you start with one side or the other. They seem to be fairly the same, except the one on the left side has cubes, where the one on the right doesn't. So that would suggest to me, I would say, well, maybe we could factor it and kind of break it down and get the right side. And we have a sum of cubes there. So there's formulas for factoring the sum of cubes. So I've got this one kind of partly done, so time to save time here. So let's see if you can follow what I'm doing. Sine cube of x plus cosine cube of x over 1 minus 2 cosine squared x. Okay. And again, remember, I'm trying to get this right here. This has to come simplified to give me the right side. Okay, so here we have it. So the first thing I did here, you can't see it, is I factored this. When you have the sum of two cubes, the first factor is the sum of the cube roots, okay? So the cube root of sine cube x is sine. The cube root of cosine cube x is cosine of x. And then the other factor is simply the square of whatever you put here, which is this one right here. And the opposite sign here, that's minus. And then the product of these two terms, sine x, cosine x, plus the second term here squared. Okay. The denominator just stayed the same. Okay. Now, going from this step to this step over here on the far right, can you see what I did? Notice the denominator is still the same. This factor here, sine x plus cosine x, that has not changed. So it's just one here that changed. And here it is. This is one of your Pythagorean identities. Anytime you have sine squared of an angle plus cosine squared of the same angle, that's going to be 1. So I simply replace this by 1. And I got this right there. Okay. Okay, so now we get here. And sometimes, to be honest with you, sometimes you just start simplifying, and then at the same time, always look at the objective. That I want to come up with this. Okay. Okay, so we're at this point right here. And again, I went to this. Okay, so how did I go from this step to this step? Okay, notice the numerator is still the same, but I put something else in the denominator. Okay, and I could have made a substitution for cosine squared, but what I did here, and again, keep in mind when you solve or prove these identities or verify the identities, there's more than one way to work them. So what I did here is I said 1 can be replaced by cosine squared of an angle, and of course since the variable is x here, I don't want to use x. You don't want to change the variable in the middle of the process. Okay, so I'm just saying cosine squared x plus sine squared x. That's the same thing as 1. Okay, so let's put it right in there. Okay, so now what can we do? Okay, well you have minus 2 cosine squared x and a cosine squared x. So the minus 2 cosine squared x and the cosine squared x combine to give me minus cosine squared x. And then I just bring the sine squared x over here. Okay, that's what I got from this step to that step. Always keeping in mind what the objective is. Okay, so now let's clear this. Now how did I go from this step to this step? Well, in the denominator I have the difference of two squares. So sine squared x minus cosine squared x, that's algebra, can be factored into sine of x plus cosine of x. The difference in the sum of the square roots. The other factor then should be sine x minus cosine of x. Okay, so now this is just like algebra. I have one factor in the denominator and the same factor in the numerator, so I can just say, okay, this one right here is going to divide out with this one right here. So in the denominator, I'm just going to have sine of x minus cosine of x, and on top, I'm going to add 1 minus sine of x, cosine of x. Okay, so that's how I get to that step right there. Okay, so let's clear this. Okay, so now from here, I want to get to this. Okay, and that's, of course, that's the answer that we want, right? Secant x, I want to get secant x minus sine x, tangent x minus 1. Okay, so now I want to go from this to this. Okay, so, and again, sometimes it works better if you focus on one thing first. Okay, so let's suppose I have this right here. I say, okay, how can I get tangent x minus 1 from this? All right. Well, notice what happens if I divide this thing by cosine of x. Okay, look, this into this and this into that. So sine of x divided by cosine of x, that's one of your identities, basic identity. That's tangent of x. And minus cosine of x over cosine of x is minus 1. Takes care of that one. Okay, but remember, whatever we do to the denominator, I have to do to the numerator. Whatever I do to the numerator, I have to do to the denominator. Otherwise, it's not legal. Okay, so I divided the denominator by cosine of x, so I have to divide the numerator by cosine of x. Okay, so now what do I have? 1 divided by cosine of x. 1 over cosine, that's one of your basic identity, that's secant of x. Okay, and then when you divide this term right here by cosine of x, obviously the cosine of x is going to cancel, and it's going to leave just with minus sine of x. And of course, this is what we're supposed to get. Okay. Now let's clear this. Now go back to this and say, well, could we have started with the right side? Okay. Can we start with this and then get that? Okay, so I'm just going to get you started here. The answer, of course, is going to be yes. I would say every time it'll work. But it might be more difficult or or might be easier. Okay, you don't know until you attempt it. And then sometimes you might be working one of these identities and you might see exactly what to do. You just go through the, like a maze. You look ahead and you see, okay, this I want to go to the right, I want to go to the left, and you got it. And sometimes you could be staring at that and you say, how the heck are you going to get to the other side? Go out for a jog or something, and you're still thinking about it, and suddenly it comes to you. But like I said, sometimes it comes to you and sometimes you have to think about it. So this is another way you could approach it. You can just say, okay, let's focus on the denominator. Say, well, how can I get 1 minus 2 cosine squared x out of tangent x minus 1? Okay. Well, let's do it this way. So in this case, this is what you would do if you're starting with the right side. And I'm just going to work with the denominator for now. So I'm going to put parentheses here. And this parentheses is going to contain this numerator, okay, just to make this easier for me instead of having to write everything down. So I'm just going to say, okay, well, tangent of x is the same thing as sine of x over cosine of x minus 1. Okay? So all I did there is I just rewrote the tangent of x. Okay, so now let's say, well, this has cosine squared there. Doesn't have tangent, so that's why I did that. Since, okay, then now let's take this, and now I'm going to multiply the denominator by cosine of x. Why cosine? Well, because I've got a cosine there. So somehow I have to get a cosine. I know that. Okay. So cosine of x. Okay, but keep in mind, if I multiply the denominator by something, I have to multiply the numerator. Okay, so this is also going to be multiplied by cosine of x. Okay. So in other words, I'm doing half the problem for you. the top here, the top, like I said, secant x minus sine x, that goes into the parentheses. So that's going to get multiplied by cosine of x. Okay, so then this gives me, in the denominator, cosines cancel out, so I'm going to get sine of x minus cosine of x. Okay. And then on the top, I still have the same thing. Okay, so I still have the sine, secant of x minus sine of x times cosine of x. Okay, so now I'm kind of going down here, I'm going to go up here. So I'm going to put equals over here. And then I'm going to say, okay, now this then is going to equal to sine squared minus cosine squared x. Now, can you see what I did there? So in other words, from this, I'm getting this. How did I do that? Well, I multiplied the denominator by sine, this should be an x here, by sine of x plus cosine of x. Okay, it's like x minus y times x plus y is x squared minus y squared. Okay, same principle here, except we're working with the trig functions. Okay, so this is okay, but whatever I do to the denominator, I have to do the numerator. Okay, so this is going to be cosine of x here. And again, remember that in the parentheses, it's secant x minus sine x. So then this also has to be multiplied by sine of x plus cosine of x. Okay? And now, I'm getting close. You can see I have a cosine squared there, minus 2 cosine squared. I have minus cosine squared here, so it's just a matter of coefficient here. Okay, so we know again from your Pythagorean identities that sine squared x plus cosine squared x is equal to 1. Okay? Which would tell me then that I can replace sine squared x, and I was solving this for sine squared x. I can replace sine squared of x by 1 minus cosine squared x. Okay, so this can be replaced right here. But that gives me then 1 minus cosine squared x minus cosine squared x. Okay, so that's going to equal to 1 minus 2 cosine squared x. Okay, so I got exactly what I want in the denominator, 1 minus 2 cosine squared x. Okay, so now to finish the problem, then you would simply multiply everything I have in the numerator. So what do I have? I have sine x plus cosine of x times cosine of x here, and then this secant of x minus sine of x. And I would rewrite the secant of x by 1 over cosine. Okay, and then multiply first by cosine, and then multiply by sine of x plus cosine of x. Do your simplification. You might have to use one of the Pythagorean identities for it to come out, but it'll come out. Okay, so you can judge from there to see which procedure is more difficult or easier. Anyway, I have some other ones I wanted to do for you, but I don't want this video to get too long, so I think I'm going to stop right here and pick it up with one more video probably on solving or proving identities using the fundamental trig identities, and then we'll go on to something else. Okay. I hope this made sense to you, and we'll catch you in the next video. Thanks for watching.